So, good morning, all. So, welcome back to the class. So, today we will be the topic related to energy balances. Like, we will be studying about the standard heat of reaction and the effect of standard heat of reaction on temperature and the problems related to that is what we are going to see today. Okay. So, let's start with the class. So first let us see what is the standard heat of reaction. Okay, what do you mean by standard heat of reaction? Okay, what do you mean by standard heat of reaction? So now standard heat of reaction is nothing but the we will be calculating related to the standard heat of formation of all components involved in the reaction. Okay, so standard heat of reaction formula is summation of standard heat of formation of products minus summation of standard heat of formation of reactants. So related to this, we have solved the problems already. Okay, now today we are going to study about the effect of temperature on heat of reaction, and this is an important derivation. Okay, effect of temperature on heat of reaction. Okay, so now what do you mean by the standard heat of reaction? Standard heat of reaction is generally we will be calling it as the enthalpy change associated with the reaction, and the conditions applicable for this standard are it should be at 298 Kelvin and what, zero point 0.1 megapascal. Okay, pressure, normal standard atmospheric pressure. So the standard heat of reaction will be called as the enthalpy change associated with the reaction, wherein the reactants and products should be at what, 298 Kelvin and all this 298 Kelvin and zero point 0.1 MPa. Okay, so now consider a reaction M plus N gives R plus SS. Okay, so now this is what a reaction which is being carried out at temperature T. Okay, where T is greater than 298 Kelvin. Okay, and the reactants and products are all in the standard state. Okay, so now consider a reaction where mm plus nn gives rr plus ss. This is what the reaction, which is the temperature is what, above 298 kelvin, on all the standard conditions has been applied. Now we have to develop a relation so that we can find the standard enthalpy change. Okay, we have to develop a relation for this equation so that we can find the standard enthalpy change. Okay, otherwise it is called a standard heat of reaction. Standard enthalpy change or standard heat of reaction. Okay, so by considering the above reactions, okay, this reaction we are considering that this above reaction is taking in three steps, and we are going to derive a relationship between the standard enthalpy change or the standard heat of reaction. Okay, so the equation is important. So now I am going to derive the relationship. So I am going to represent, we are going to consider that the mm plus nn gives rr plus ss in three steps reaction. For this we are going to consider that three-step reactions. For that we are going to, I am going to draw a flow chart like thing. Okay, so first is reactants at T. Okay, the reactants are at temperature T. Okay, so now this will be at products at T. Okay, so this is what a single step reactants and T. So now the desired change, whatever the reactions will be taking place. Okay, the reaction is taking place at T, and you are getting the standard heat of reaction, that is del H0 RT. This is what our main. Okay, instead of this, now this is going to take place at a three-step reactions. Okay, so now what is happening is cooling is taking place. Now cooling is taking place. The enthalpy change related to that will be called as del H1. So now the reactants will be at 298 Kelvin. From T, the temperature has been reduced to 298 Kelvin. Okay. So now the temperature has been reduced to 298 Kelvin. Now the reaction is taking place at 298 Kelvin, and then this del H2 will be equal to del H0 R, because this is the standard condition. Okay. So now after this we are getting the products at, after, since the reactions are taking place in 298 Kelvin, you will get the products also at 298 Kelvin. After this you are heating this. Okay, and the enthalpy change related to this is del H3. So you are getting the products at T. So listen, so this MM plus NN gives RR plus SS will be the our reaction. The temperature is what? T, and that is above 298 Kelvin. So we have going to derive a relationship for the finding the standard enthalpy change by considering this reaction taking place in three steps. Okay, that is what I have explained here. Now first the reactants at T, what is our consideration? Okay, so first we are cooling the temperature, and the enthalpy change corresponding to this is del H1. So from T the temperature has been reduced to 298 Kelvin. Now the reaction will be taking place at the 298 Kelvin only, and the del H2, okay, the enthalpy change is del H2. Since it is 298 Kelvin is the standard condition, we are taking it as del H0 R. Now, after the reaction taking place, you will get the products. The products also will be at 298 Kelvin, because here the reaction is taking place at 298 Kelvin. So, now this is the first step, this is the second step. Okay, now the third step is we want the products at a temperature T. So, now we are heating it. So, we are getting the products at T. So, this is a single step. This part shows the single step directly. So this can be taken place by the three-step reactions also. Now first one by one we will do the derivation. So the step 1, okay, what is the step 1? The reactants are cooled from temperature T to 298 Kelvin. The enthalpy change for this temperature is given as T to 298, right? So it is given as Ni Cpi R dt. This equation number 1, where this R represents the reactants. Okay, Ni is nothing but the stoichiometric coefficient of ith component. Okay, stoichiometric coefficient of ith component. Stoichiometric coefficient of ith component. Okay, so now next is for step 2. Okay, so in the step 2, the reactants will be converted into products at 298 Kelvin. The, what is happening in the step 2? The reactants will be converted into products at 298 Kelvin, and the reaction will be allowed to occur at 298 Kelvin, and the enthalpy change is given as del H2. We are taking it as del H0 R, because this is taking place as standard heat of reaction. Okay, this is called as standard heat of reaction at 298 Kelvin. This is equation 2. Okay, this is equation 2. Okay, and the next is step 3. In the step 3, what is happening? The products are heated from 298 Kelvin to temperature T. Okay, the products are heated from 298 Kelvin to temperature T. The enthalpy change associated with this step will be given as del H3, that is 298 to T sigma Ni Cpi of P dt. So this is equation 3. So here where P represents the products, okay, where P represents the products, okay. So now total enthalpy change, just a second. Okay, so total enthalpy change is being given as, so enthalpy change of step 1 to 4 can be written as enthalpy change of step 1 to 2 plus enthalpy change of step 2 to 3 plus enthalpy change of step 3 to 4. So now we can write this as del H0 RT is equal to del H1 plus del H2 plus del H3. Okay, this is equation 4. So now substitute all these equations to 1, 2 and 3. Okay, substitute equations 1, 2 and 3 in equation 4. So you will get as del H0 RT is equal to T2 298 sigma of Ni CPI of R dt plus del H0 R plus 298 to T sigma Ni CPI naught of P dt. Okay, so now these two we will combine that temperature as like 298 to T, so that this will 298 to T we will take. So that this will become this minus this. T to 298 means this plus this. When we are taking as T to 298, this will become minus. So del H0 RT, del H0 RT is equal to del H0 R. This del H0 R plus 29, sorry, 298 to T. These two we are combining. So this is T to 298, this is 298 to T. So we are going to take it as 298 to T. So this will become minus. So sigma of Ni CPI naught of P minus sigma Ni CPI of R the whole dt. Okay, so this is equation 5 and this is equation 6. Is it clear? So now Cp naught value. Okay, the value of Cp naught is given as A plus Bt plus Ct square. So that sigma Ni Cpi naught of product of P, sigma Ni Cpi of P can be written as, how will we write? This is the equation, right? Product. Okay, so R Cp naught R plus S Cp. Ni is the number of moles. Okay, so for this you can write it as, I will write the equation here. Okay, I will write this equation here for our reference. This mm plus N gives RR plus SS. So sigma of Ni of CPI of P. That is sigma of products. Okay, N is nothing but the number of moles. So this can be written as number of moles for R is R. CPI, Cp instead of I, you will get R plus S CPS naught. Okay, so this can be written as R into, for Cp naught value, you have what is the equation? A plus Bt plus Ct square of R plus S into A plus Bt plus Ct square of S. This is equation 7. Same way, sigma of Ni Cpi of reactant had been written as M Cp naught M plus N Cp naught N. So this again can be written as M into A plus Bt plus Ct square of M plus N into A plus Bt plus Ct square of N. This is equation 8. So now we have to find sigma Ni Cpi of P minus sigma Ni Cpi of R. That is what in the integration equation we have written. So R into A plus Bt plus Ct square of R plus S into A plus Bt plus Ct square of S minus M into A plus Bt plus Ct square of M plus N into A plus Bt plus Ct square of N. Okay, N. This you will get like this. So now you multiply this. Okay, expand the equation. So R plus R multiplication R BRT plus R CRT square. Okay, just multiply and expand by substituting the suffix. SAS SAS plus SBST plus SCST square. Okay. Minus same MAM plus MBM T square. Sorry, T plus MCM T square plus NAN plus NBN T plus N small and capital will come NCN T square. NCN T square. Now combine RAR and RAR and SAS and then MAM and NAN, like that you combine. Okay, that is terms. So how will we write this? RAR plus SAS minus MAM plus NAN plus RBR T plus SBST minus MBMT minus NBNT. Like that we are combining the terms and writing. Okay. So now the same equation can be written as sorry, RA, sorry, RAR plus SAS minus MAM plus NAN. Okay, this is one parameter. Plus RBR plus SBS. Okay, T we will take it as a common. MBM plus NBN into T. Okay, into T plus RCR plus SCS minus MCM plus NCN into T square. So just we have combined these two plus minus these two. Same way these two plus minus these two plus. Okay. So these two plus minus these two plus. Okay. And taking T as a common out. Then these 2 plus minus what? These 2 plus and taking t square as a common out. Okay. So like that we have written. Okay. So this is equation number 9. Now what we will do is this we will take it as del A. Okay. And this we will take it as del B and this we will take it as del C. So del A can be written as R A R. Okay. RAR plus SAS minus MAM plus NAN. And del B is written as, okay, RBR plus SBS minus MBM plus NBN into T. Sorry, not T. T is not been taken. Okay, only these parameters. T, T square and all is as such. So, as such as, just a second. Okay, so del C can be written as, again del C can be written as R C R plus SCS minus MCM plus NCN. Okay, so now when you substitute all these values over here, you will get as sigma Ni CPI. Okay, so all this you substitute equation 10 in equation, and just a second. This. So this you take it as equation 9. Okay, this take it as equation 9. So now this is equation 10 and this is equation 11. Now substitute equation 11 in equation 9. So you will get sigma Ni Cpi of naught P minus sigma Ni Cpi of naught R will be equal to del A plus del Bt plus, sorry, not substitute equation 11 in equation 10. Okay, 11 in equation 10. Here you substitute. You will get it as sig del A plus del Bt plus del C t square, because for this del A, for this del B, and for this del C. So you will get a sigma Ni Cpi of P minus sigma Ni Cpi of R is del A plus del Bt plus del C t square. Okay, so now this equation, this is equation 12, substitute 12 in equation 6. Substitute 12 in equation 6. Okay, substitute 12 in equation 6. So which is the equation 6 here. So now for this you have to substitute as del A plus del B t plus del C t square. So now what you will get is del H 0 R t is equal to del H 0 R plus 298 to T del A plus del B T plus del C T square dt. Okay, equation 13. Equation number 13. Okay, equation number 13. So now this can be written as, okay, this after substituting this del H0 RT is equal to del H0 R plus del A into, after substituting, integrating and substituting limits, T minus 298 plus del B by 2 into T square minus 298 square plus del C by 3 into T cube minus 298 cube. So now this will be reduced into a symplectic form for temperature T as del H0 RT is equal to del H0 plus del AT plus del P by 2 T square plus del C by 3 T cube. So this is what the final equation. Now we will be using to find the standard heat of reaction. So you should remember this formula for solving the problems. You should remember this formula for solving the problems. Okay. So now once again I repeat. So effect of temperature on heat of reaction we have studied. For this we have considered this reaction. MM plus NN gives RR plus SS. Okay, so we have taken all these three steps, reactants and T. Okay, that is the first step is the step 1 is the reactants are cooled from temperature 2 to 298 Kelvin and the enthalpy change has been written. And the same way for step 2, it is the reactants are converted into products at 298 Kelvin. Since it is a standard condition, we have written like this. And the step 3 is the products are heated from 298 Kelvin to temperature. The enthalpy change associated with that is given like that. So the overall change in enthalpy is given as del H0 RT is equal to del H1 plus del H2 plus del H3. Substituted all these values and combined these two terms. Now we have got like this. Now we are going to find the value for this. Okay. So Cp naught is given as A plus Bt plus Ct square. So first we have taken for products and we have written. Then we have taken for reactants and written like this. So products minus reactants and we combined all the terms together. And afterwards we have given notations as del A, del B and del C. So finally we will get it as del A plus del Bt plus del C t square and substitute in the equation, integrate and we have got a equation, and this equation is very important. Now let us solve a problem related to this. Okay, so now what they have given is obtain an empirical expression relating, okay, we have to get the expression relating the heat of reaction and the temperature of reaction. That is what we have to get a equation of this form, okay, relating the heat of reaction and the temperature of reaction for the following reaction. Okay, so SO2 plus half O2 gives SO3 gas. So using the same expression, we have to also calculate the heat of reaction at 773 Kelvin. Heat of reaction at 773 Kelvin. So now they have given us component is given. Okay, component is given, and they have given the standard heat of formation data, and also component is given, and they have given A, B, C, D. So from this we have to find del A, we have to find del B, del C and del D, because the formulae what we have is what? Del H 0 RT is equal to del H 0 plus del A plus what? Del B by 2, del AT plus del B by 2 into T square plus del B C by 3 into T cube and so on. Okay, same principle we have to find it. So now we will start with the problem. So now for this we will find the del H 0 R, that is standard heat of reaction, that is sigma of del H 0 formation of products minus sigma of del H 0 F of reactants. Okay, so the same thing we will do first. For the first given data we will do, that is SO2 plus half O2 gives SO3 of gas. So the standard heat of reaction will be del sigma of del H 0 F of products minus sigma of del H 0 F of reactants. Okay. So now this will be data is been given. So the number of moles is what we have to consider. O2 data is not given. So we have to take as 0. Okay. So you will write as 1 into minus 395720 minus of 1 into minus 296810 into plus 1 by 2 into 0. So you will get the answer as minus 98910 kilojoules per mole. Now the standard heat of reaction. The next is what? Standard, this is del H 0 or this is heat of reaction. Okay, heat of reaction we have found. The standard heat of reaction. Next is we have to find standard heat of reaction at any temperature T is given as, we have to derive an expression. Okay, del H 0 or T is equal to del H 0 plus del A T plus del B by 2 into T square plus del C by 3 into T cube plus del D by 4 into T power 4. Okay, so now first we have to, it will go off. Okay, if it is 5, it will get del E by 5 into T power 5. So first we have to find del A. How will you find the del A is? Okay, so the reaction is SO2 plus half O2 gives SO3. Okay, del A is nothing but products minus reactants. Okay, products minus reactants, that is 1 into 22. Okay, 1 into 22.036 minus, okay, 1 into 24.771 plus half into 26.026. Always products minus reactants. So del A will be now 1 into 22.036 minus 1 into 24.771 plus half into 26.026. So the answer is minus 15.748. Same way del B, okay, into 10 power 3. So usually when I told, when we have to write Cp naught, you will write as 10 power minus 3, 10 power minus 6 and 10 power minus 9. Same thing, even though here it is given in positive, final thing you have to take it as minus 3 only. Whatever answer you are getting, that is products minus reactants into 10 power minus 3. You remember this, into 10 power minus minus. Always Cp naught when you are taking, it should be in minus only. Okay, now the next is del B we have to find. Okay, so what is del B? 1 mole and 1.5 moles. So that is 1 into 121.624 plus, sorry, minus 1 into 62.948 in plus 1 by 2 into 11.775. Same way you have to find for del C, del D. Okay, Del P is 1 into 121.624 minus 1 into 62.948 plus 1 by 2 into 11.755 into 10 power minus 3. This minus, even though they gave in plus, they should be minus. So 52.799 into 10 power minus 3. Same way you have to find del C. Okay, del C also products minus reactants. So 91.861 minus 1 into 44.258 plus 1 by 2 into minus 2.343 into 10 power minus 6 finally. So the answer is minus 46.438 into 10 power minus 6. Okay. So same way you find for del D. That is 1 into 24.369 minus 1 into 11.122 plus 1 by 2 into minus 0.5621 into 10 power minus 9. So you will get the answer as 13.526 into 10 power minus 9. So now del H0 RT, sorry, del H0 RT will be del H0, okay, minus del AT, that is minus 15.748 T plus del B by 2 T square. So now substitute the del P value 52.799 into 10 power minus 3 by 2 T square plus del C by 3 into T cube. Del C is minus. So 46.438 into 10 power minus 6 by 3 T cube plus d by by 4 into t power 4. So that is 13.526 into 10 power 9 minus 9 by 4 into t power 4. This this formula we are substituting. Okay. So now we have substituted. And then next is, okay, so now solve this, okay, divided by 4 and all this, solve this. So you will get the equation as del H0 RT is equal to del H0 minus 15.748 into T plus 26.3995 into 10 power minus 3 T square minus 15.479 into 10 power minus 6 t cube plus 3.382 into 10 power minus 9 t power 4. So now already we have found the standard heat of reaction. Okay, this already we have found the standard heat of reaction value. Okay, that is del H 0 RT at 298 Kelvin is what? Minus 98910 kilojoules per mole. Now substitute this value over here. Okay, all these are at 298 Kelvin, right? So substitute this value over here and for T substitute 298 so that you will get the del H0 values. Okay. So now minus 98910 is equal to del H0 minus 15.748 into 298 plus 26.3995 into 10 power minus 3 into 298 square minus 15.479 into 10 power minus 6 into 298 cube plus 3.382 into 10 power minus 9 298 power 4. So when you do this, okay, and solve, you will get minus 98910 is equal to del H0 minus 469. We're just solving. 2344 minus 410 plus 27. So now del H0 is equal to minus 96178 and all these are at 298 Kelvin. Okay, 298 Kelvin. So now they ordered us to find what? Del H0 R What is the given problem? They have given at T is equal to 773 Kelvin. They have asked us to find the reaction at what? That T is equal to 773 Kelvin. So now at 298 Kelvin, del H0 is what? Minus 96178 at 298 Kelvin. Now we have to find the standard heat of reaction at 773 Kelvin. So this del H0 always will be at standard condition only. So this equation will become as minus 96178 minus 15.748T plus 26.3995 into 10 power minus 3T square minus 15.479 into 10 power minus 6T cube plus 3.382 into 10 power minus 9T4. This is called as the empirical equation for standard heat of reaction at temperature T. Okay, so what is being asked in the problem is obtain an empirical expression relating the heat of the reaction and temperature of the reaction. So here the temperature of the reaction is T. Okay, so now what happens is always this value first will be given. Okay, first you have to find del A, del B, del C and del D and all. Okay, and then by having this value, you will find the del H0 value at 298 Kelvin by substituting T is equal to 298 Kelvin. And after that, you will get an expression del H0 value you will get. Once again, you will substitute the del H0 value and you will write an expression that is called as an empirical expression. So once again, I explain in this problem. Okay. So here what we have done is first they have not some problems they will give the standard heat of reaction value. Here they have not given and they have asked us to find. Okay, by giving this data. So for by using this data, first we have found the standard heat of reaction. So now for finding the empirical expression, the standard heat of reaction at any temperature T is being given as del H0 RT is equal to del H0 plus del A plus del B. So now by giving this data, we have found del A, del B, del C, del D. And remember all this will be coming in negative sign. Okay. So now we have got the values and we have substituted. So now we will be getting an expression like this. After solving all this, you will getting an expression like this. Now what we have to consider is we have to consider the temperature as 298 Kelvin, and already we will be knowing this del H0 RT and taking the condition as or this condition at 298 Kelvin. 298 Kelvin is the standard condition. What we have to find? You have to find the del H0 value by substituting T is equal to 298 and by substituting the del H0 RT, that is standard heat of reaction value. Now we will get the del H0 value. Now after that, this again the same equation, you have to substitute the del H0 value and all the T's will remain as such because this is at any temperature T. And some problems they will just stop with this empirical expression. They will not ask further. But in this problem they have asked us temperature is equal to 773 Kelvin. So now here for this T, substitute 773 Kelvin in the above equation and you will get a value for del H0 RT. Okay, so del H0 RT is equal to minus 96178 minus 15.748 into 773 plus 26.3995 into 10 power minus 3 into 773 square minus 15.4793 into 10 power minus 6 into 773 cube plus 3.382 into 10 power minus 9 into 773 power 4 is equal to minus 98.98519 kilojoules per kilomole. So this can be written as minus 98.519 kilojoules per mole. Okay, kilojoules per mole because they have asked in kilojoules per mole. So always remember, first some problems this data will be given directly. Del H 0 or data will be given directly. If it is not given, you have to find the del H 0 by, they will give the standard heat of formation. Then you have to find del A, del B, del C, del D, and you will get an expression like this. And after that, we have to take the temperature at 298 and you have to find the del H 0. After finding the del H 0, you will get again an expression with respect to T. Just the same equation, you will substitute del H 0. Now, if the temperature one more temperature is not given, this will be our empirical expression. So in this problem, they have given the temperature as 773 Kelvin. So we have substituted T is equal to 773 Kelvin and we have found it. Okay, so the another two problems are there that we will see in the next lecture. Okay.